Hey everyone, my name is Dilruba Showkat. I'm a PhD student at Northeastern University. I'm happy to present our paper titled Who is the Right Homeless Client? Values in Algorithmic Homelessness Service Provision and Machine Learning Research. Homelessness presents a long-standing problem worldwide, including the United States. In January 2020, more than 77,000 people have experienced homelessness in New York City alone. In order to optimize and scale housing allocation for these large vulnerable communities, research practitioners have used machine learning algorithms. These algorithms are often applied to solve risk factor prediction, high-risk client prediction, and policy recommendations. Some of these algorithms include statistical modeling techniques such as t-test, predictive modeling that includes decision trees and logistic regression models, and recent works have applied rule-based optimization methods and deep neural networks. These ML techniques enable fast and efficient decision making. However, they raise increasing concern because unhoused persons are vulnerable and prioritization of different ML values can cause unintended harms and consequences. Meet Monique, who is 64, a male homeless client from New York City. His values include autonomy, privacy, and identity. However, we are unaware of what values are encoded in ML homelessness service provision research that are developed to support unhoused clients like Monique. Inspired by all of this, and in order to deeply assess this concern, we asked the following research question. First, we wanted to look at what values are encoded in ML research for homelessness. Secondly, we wanted to understand the impact of prioritization of different ML values. Third, we wanted to explore homeless populations and how they are positioned in data and algorithms. Our methods included a two-step process. In the first step, we conducted a systematic literature review of papers spanning from CS and STS. We conducted a keyword-based search across major databases. Our initial corpus included 100 papers. However, in order to focus on our research question, we included 40 papers in the next step of our analysis. You can find the list of papers in supplementary materials. During thematic analysis, we conducted both inductive and deductive coding. For deductive coding, 67 values were borrowed from Birhan et al. 2022 paper GitHub page. Moving on to results. In response to research question 1, we found novelty, performance, and identifying limitations were uplifted in the papers. We further observed that novelty often manifested as proposing novel algorithms for CS-focused papers and identifying novel risk factors for STS-focused papers. In all these discussions, humans were always placed as secondary. That's why we started questioning the research approaches and conducted further analysis to see how this values prioritization have impacted other values. So this led us to observe several values have collapsed, which we defined as any ML values that requiring redefinition as they broke down or no longer uphold their true definition as we know it in ML. We found privacy, efficiency, cost, fast, reproducibility values have collapsed. Remember Monique? So privacy was one of his core values. However, it collapsed in several ways. Privacy values collapsed when unhoused persons entered the homeless system. The staff volunteers have asked them uncomfortable questions they meet for the very first time. The research team was also at the forefront when they have asked uncomfortable or even invasive questions. Here is one example where authors have asked homeless youth what kind of things they had done to get by on the streets when they had few other options. You can find further excerpts across all the values collapse in our paper. So we also wanted to look at what algorithms and performance matrices have caused these values to collapse. We found logistic regression being the most highly used algorithm across 50% of the papers have contributed to this values collapse. Similarly, accuracy AUC matrix that was used in 90% of the papers have contributed to this values collapse. Lastly, moving on to the last research question, as these values were collapsing, we found that humans were lost or nullified, that is, they were deprioritized in the descriptions. Humans were lost when research focused on predicting the right who by using classification techniques to identify who will cost more in the future, who will benefit the most. Humans were also lost when research have focused on identifying novel risk factors, and they have tuned parameters specific to certain algorithms. In all these ways, humans were lost at multi-level of ML abstractions. Furthermore, crosstabs showed novelty and performance values have equally contributed to this manifestation of loss of humans across CS and STS paper, despite having an unequal sample size across CS and STS papers. In this figure, we show that we found the values that were uplifted in the ML research for homelessness and the impact as values collapse. And we also show that humans were lost as a result of all of this. Our findings have several implications. First, we propose that our findings have implications for producing research that are accountable in the homelessness context. We also propose future direction that sits at the intersection of data science, CS, and STS by centering homeless stakeholders. We provided several responsibilities for HCI in our work. First of all, HCI researchers can prioritize human values in the ML service tool design, such as autonomy and privacy. Homeless clients' autonomy can be uplifted by asking key questions and using those responses in the ML service tool design. For example, homeless clients can be asked what information about them should or should not be used, which one should be weighted less or more, and by how much. How unquantified histories and untold stories can and when and should work as a proxy to the outcome they receive. Homeless clients' privacy can also be protected by using novel experimental techniques that do not rely on real data used in the ML pipeline. Finally, HCI can support homeless clients by providing them with practical job training, educational support, and creative skill development support. Existing design methods such as participatory design and others can be used for these purposes. We also suggested several implications for technical side. So we wanted to recommend researchers to uplift simplicity, to develop methods that are simpler and that would not cause any resource burden to the homeless system. In that way, the research would be easy to disseminate and support reproducibility and replicability in ML research. Lastly, we should focus on high-quality data discovery and curation technique using existing methods that are developed in other domains. Lastly, there are several key takeaways of our finding. Most importantly, in this work, we complicate ML research for homelessness by showing how humans were nullified or lost in predictors. They were re-victimized to the rank of human sufferings through high-risk calculation and double stigmatized by computation. We believe this should change so that Monique's values are not disconnected from ML research in the homelessness context. Lastly, I would like to thank anonymous reviewers and ACs for their valuable comments and feedback. We are grateful for all the great work that came before us that make this work possible. And thanks everyone for listening to this talk.